everybody. Let's do a takeaway from Monday. So we talked about linear motion and circular motion. And here's an example of designing a pair of parametric equations for linear motion. What if I want to go from one point to another point between time 2 and time 4? You're supposed to design a pair of parametric equations. So if you think about what does that mean, that means we want equations for x of t and y of t, so that when I plug in 2 for time, x will give me 10 and y will give 2. And if I plug in 4 for time, x will give 5 and y will give 3. It might not seem obvious how you can just write the equations down right away. And this is like most math problems. You can't just jump to the answer straight away. You have to use thinking tools. So the thinking tools are using a table of the information you know about the functions, or graphs for what you know about the functions. And if you organize this information that's in words using one of those tools, maybe it'll be more apparent how you can actually write the equations you need. So let's check it out. So what I said was at time 2, the x-coordinate should be 10, and at time 4, the x-coordinate should be 5. At time 2, the y-coordinate should be 2, and at time 4, the y-coordinate should be 3. Okay, so if I want to find an x of t equation, that's like a function that relates time to x. So if you're used to thinking about functions from tables, I know it's going to be linear motion, so it's going to be moving in not only in a straight line, but at a constant speed. You could think, okay, when there's a change of 2 seconds, I want the x-coordinate to decrease by 5. And maybe that's enough for you to write an equation. I don't like to think in terms of tables. I like to think in terms of graphs. So let me show you how I would organize it. So here's a graph. I haven't done it yet, but this will be a graph for x of t. So on this axis, I've got time going from 2 to 4 seconds. And I can put that same information in. So at 2 seconds, I want the x-coordinate to be at 10. At 4 seconds, I want the x-coordinate to be at 5. If you're thinking, wow, he really didn't do a very careful job with the axes here, you're right. Because I'm not interested in making like a perfectly accurate graph that's to scale. My only goal is to help cue myself for how can I actually write an equation that describes this information. And now that I've written it down this way, I'm thinking, aha, I know how to write equations for lines. It looks like in this direction, when I go up by 2 seconds, here I'm going down by 5. So if I think what's the slope of that line, it should be negative 5 halves. So now I can just start writing the equation. We've been working with the point-slope form of the line, so that's what I'm going to continue to do. So I'm going to take a line with that slope, but now I'm going to shift it right by 2 and up by 10, so that I know it goes through this point. So here I'm going to shift it right by 2, and then up by 10. So I know that that should fit this curve. Of course, this equation continues in both directions. But I didn't say in the problem what I wanted it to do outside those time bounds, so that's fine. Let's write the equation for the y function. So at time 2, what am I doing? At time 2, I want a y-coordinate of 2. At time 4, I want a y-coordinate of 3. And so it looks like the slope here, if I go up by 2, I'm going to go up by 1. So the slope should be 1/2. So I'll write 1/2, and then I'm going to shift it right by 2 and up by 2. And there we go. So again, what I want you to take away is not necessarily, oh, I'm going to ask you a question that looks exactly like this, and you should do exactly that. I might ask you lots of different questions, but if you're ever thinking, wow, I need an equation, but I don't know how to think about it, remember, organize the information you know as a table or a graph, and it might become more apparent how you can write the equation you need.